Hello everybody and welcome to the Carlam Cymru revision sessions. This session will focus on the intermediate maths GCSE and will be presented by Mr Walters from our Gowerton School. The session will last around 45 minutes where Mr Walters will run through the relevant subject content. If you have any questions during the session, please use the question and answer section within this live event and we'll do our best to answer your questions. The session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carlam Cymru tab. Thank you, Mr Walters. Over to you.
Thank you very much. Hi, everyone. Today we're going to look at something called product of primes. And I shall start off with this. First of all, we need to know what a prime number is. So before I continue, I'll just mention to you this is a webinar, so you can stop the video at any time, attempt the questions, and when you're ready to resume, you can press play. So that's how we'll run it. Okay, so there's 4 questions there, so maybe if you stop and try those questions, and I'll resume in a moment. Okay, so here we go then. The first 6 prime numbers. 1 is not a prime number. The first prime number is 2, and then you have 3, 5, 7, and 11. Okay, those are the first 5, sorry, and then 13. Right, first of all, what is a prime factor? A prime factor is a number that divides into a chosen value. So I'll write this down. Okay, so that's a prime factor. It's actually it's a prime number that divides into a chosen value. A product is simply a multiplication sum. And the last question, it asks, what is a product of prime factors? And we're using a few of the definitions above. It's a multiplication sum. Using the prime numbers. Actually, using the prime factors that divide into a chosen value. Okay, so the last one, product of prime factors, a multiplication sum using the prime factors that divide into a chosen value. Okay, right, so a few things after that. I'm going to show you 2 examples here. I'm going to simplify the following product, which is a multiplication sum of prime numbers. These are prime numbers, and I'm then going to put them in index form. Okay, so this is what I mean. There's 3 2's. So I say it's 2 to the power 3 times and if I look at these two together, it's 3 squared. So those are a product, a multiplication sum. They are prime numbers, 2 and 3 being prime numbers, and they're written in index form. There's 3 2's, so it's 2 to the power 3. There's 2 3's, so it's 3 to the power 2. Okay, and the next one, if I group those off together, there are 4 of them. So it's a case of saying 3 to the power 4 times, don't forget to put that times between them, 5, and there's 2 of these, 5 squared. So they're a product of prime numbers and they're in index form. Okay, so what I'd like you to try now is just 2 questions, and if you so wish, you can pause the screen. Here are the 2 questions I'd like you to try there. And this is what we should have as an answer. There's 3 2's, so I'm going to say 2 to the power 3. Don't forget it's a times or multiplication. And there's 3 5's, so it's 5 to the power 3. So we've got an answer 2 cubed times 5 cubed. The next one, there's only 2 2's, so it's 2 squared times 3. And there's 4 of them, so it's 3 to the power 4. So the answer to the second one is 2 squared times 3 to the power 4. Okay, so using those skills now, I'm going to move on and I'm going to do a typical exam question for 3 marks. Okay, this is how it'll be worded. It'll ask you to express a value as a product of prime numbers in index form. And that is one way of doing the work. There are 2 ways that people tend to use. This is what I've adopted, and I will show the other way quickly. So we keep dividing by the lowest possible prime number. We're going to stop when the last number becomes 1, and we're going to write the prime numbers out as a product or a multiplication sum, and then we're going to write them out as a product using indices. Okay, so I'll show you such an example here. So we've got 88. I'll write 88 like this. And the lowest possible prime number that goes into 88 is 2. 2 goes into that 44 times. I'm dividing going down the page now, not going up the page as you might be used to. 2 goes into that because it ends in a 4. 2 into that is 22. 2 goes into 22 11 times, and 2 goes into 11 once. So I've kept dividing through by the lowest possible prime number. And oh, sorry, made an error here. 2 does not go into 11. 11 goes into 11 once. Okay, so those are a list on the left hand side here are a list of the numbers. They're all prime numbers. So we're now going to write them out as a product. And then we're going to put them in index form. So there's 3 2's, so it's 2 to the power 3 times 11. Some people put the 1 there. There's no need if you don't wish. If you are going to put the 1 there, make sure it does not look like 111. Okay. Point for you, something to mention here, you may do that division incorrectly. That's where people tend to fail. If you do that incorrectly and only make 1 error, you can get a mark if you write this down according to your numbers on the left hand side, and then a mark for that. Okay, so I would encourage you to write out the product, then write it in index form, because if you do make an error there somewhere, only 1 error, you can get the next 2 marks, but it tends to be marked out of 3. So I happen to have done it right, so there's 3 marks. Now I've done it by dividing. Some people would rather use trees as follows. So I will show this method. 88 was the number. Now I think this method is fine when the numbers are easy and small. When the numbers become more challenging, people end up doing the division anyway. But here goes. 2, you're using a prime number, 2 times 44. That is a prime number, so I'm going to circle it. 2 goes into that. It's a prime number, and I'm left with 22. 2 goes into that 11 times. So what I've got then is the same system. 2 times 2 times 2 times 11, or in index form, 2 cubed times 11, or 11 to the power 1. Okay. I'd encourage the top one, because when the numbers get more challenging, you know how to divide, and you'd have to do a division here anyway. The second example, 81 is the number I've selected. Okay, so I would write 81 down. Now, 2 does not go into it because it doesn't end in 2, 4, 6, 8 or a 0. I've got to check does 3 go into it. Now, you should know the divisibility by 3 law. If I add up the 8 and the 1, they give me 9. Now, 3 divides into 9, so I know that if I divide this by 3, there is no remainder. So I'm going to start off the first number being 3. 3 into 8, 2 3s are 6, carry 2. 3 into 21 is 7. I should know that 3 goes into 27 from my 3 times table, 9 times. 3 goes into 9, 3 times, and 3 goes into 3 once. So I should end up with, and I would encourage you to write this out, sorry, 3 times 3 times 3 times 3. It's everything you see. All the factors are on the left-hand side. And then there's 4 of them, so you simplify it, 3 to the power 4. 3 marks, 1 if that's correct, 1 if that's correct, 1 if that's correct. Okay, we'll show this once again if you prefer this system. 81. Now I might not know that it's 3 7s to give me 81, so I'd probably have to do division anyway. But anyway, there's 3 27s rather. I'd probably have to go and do that on the side anyway. Now 27, I should know that 3 goes into that. 3 9s are 27, and 3 3s give me 9. You multiply everything I've circled, and there's 4 3s, so it's 3 to the power 4. Okay, so in summary, you keep dividing by the lowest possible prime number from my preferred method until you get to a 1 on the bottom. You multiply, you put them as a product of the prime factors, then you put them in index form. Okay, so there's an exercise for you to do here. There's 3 questions. This is probably a wise place for you to pause and then play when you're ready to check the answers. So I'm going to pause for a moment. You should pause to see what you produce, and let's check our answers in a moment. So the first number was 196. So I'm going to do it here. 196. It ends in 6, so I know 2 goes into it. 2 into 19, 9 2s are 18, carry 1. 2 into 16 is 8. 98 ends in 2, so 2 divides into it. 2 into 9, 4 times, carry 1. 2 into 18, 9 times. Now 2 does not divide into 49. The next prime number is 3. 3 does not divide into 49. Next prime number is 5. 5 does not divide into 49. The next prime number is 7. You should know that 7 divides into 49 7 times. and 7 divides into 7 once. So these are a list of the prime numbers or the prime factors. Write them out in index form. Write them out as a product, then in index form. Sorry, 2 squared, there's 2 of them, times 7 squared. Okay. Now, there is a way of checking it. 2 squared is 4. And 7 squared is 49. And 4 times 49 should give me the 196 that I've got there. Okay. The next value is 200, so I'll show you the answer or the solution here. You can divide that by 2 because it ends in 0. You can divide that by 2 because it ends in 0. You can divide that by 2 because it ends in 0. This doesn't end in 2, 4, 6, 8 or 0. So I've finished with 2. 3 does not divide into 25. The next prime number is 5. So 5 goes into 25 5 times, and 5 goes into 5 once. All the prime numbers or the prime factors are on the left-hand side. I'm going to write them out as a product. For the second mark, and then I'm going to put them in index form. There's 3 2s, so it's 2 cubed. There's 2 5s, so it's 5 squared. That's the answer for 3 marks. I'm going to check it. 2 cubed is 8. 5 squared is 25. 8 times 25 is the 200. So I'm happy to go with that. 1 mark, 2 marks, 3 marks. Okay, the next value is 64. So you can divide it by 2. Divide that 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 by 2. Once again, I would write them out. 1, 2, 3, 4, 5, 6 2s. 1, 2. Yeah. So I'm going to say it's 2 to the power of 6 when it's put in index form. Right, moving on. What you're often asked as a 1 mark question is what I'm going to try and show you now. Now, all the square numbers, when we do this calculation to put them as a product of prime numbers in index form, you will notice, and you know, this is, if I was in my own class, I would do a long list of numbers, some square numbers, some not square numbers, and we would discover that all square numbers have an index value that is even. 2 is an even value. So if I didn't know about 25, I can tell simply from 5 squared that because this is an even value, the index value is even, it's a squared number. 2 to the power 6, 6 is an even value, the index value is even, so therefore I know that 2 to the power 6 is a square number. Without knowing that the answer is 64, I know that's a squared number. The same with these. Now this has got 2 squared. That there is an even number, and that there is an even number. Even numbers are obviously 2, 4, 6, 8, and so on. Okay. So you're sometimes asked, are certain values or certain product of prime numbers in index form, are they square numbers, yes or no? So if I show you what might be an exam question, 2 to the power 1 times 5 to the power 1, you're just simply asked, is it a square number, yes or no? And I would say with this question, I would say it's no. It's not a squared number because these index values are not even. I should say not even index values. You can't say not even values. You have to say index values or powers. With the number 200, the 5 is to the power 2, that's good. But this year, 2 to the power 3, the power of 3 or the index value of 3 is not an even value. Okay, so therefore it's not, if you were asked, is it a squared number, you'd say no. And you would say exactly the same as what I said there. It's not an even index value. Or should I say, one of the powers is not an even index value. One of the powers, because the 5 squared is, one of the powers is not an even index value. Okay, so if the powers are 2, 4, 6, 8, then on both powers, because there's 2 powers here, isn't it? We consider both values. If both of them are a 2, 4, 6 or an 8, then you can say it's a squared number. All right. 100, by the way, up here, 100 is a squared number. You know that 10 times 10 is 100. It's a squared number. That's why it's a yes. 200 is not a squared number. That's why it's a no. Okay. So with these questions here, all 4 of them, you simply have to say whether they are squared numbers or not, and you have to explain why they are squared numbers or not. Okay, so you have to say the powers are square or the powers are not square. Sorry, the powers are even, or the index values are even, or the other way around is saying that the index values are even and not even, therefore they're not squared numbers. So I'd like you to try those 4 questions. Pause the video and then press play when you're ready to resume. So you've tried those. Powers are both even. So I would say yes, whatever that value is a squared number, because you would need to say even index values. Right? The index values are 2 and 2. I highlighted them. Question 2. That is an even index value, but unfortunately, this one I've highlighted. Oh, sorry, I haven't highlighted very well. This one has a power of 3, suggesting that the number, right, the number is not a squared number. No, it's not a squared number because the not even index values. Okay, that is actually the same as the question above. 2 cubed times 5 squared is this here, it's 200. You won't be told it's 200. I mean, you could work it out to be 8 times 25. Normally the numbers are very, very large, but you can tell straight away that is not an even index value because the power 3 is not even. Okay. With question 3, it's a yes. And you would say it's even index values. And question 4, there's a 3 there. If it's not put in, it's to the power 1. That section there. 3 on its own is 3 to the power 1. Now, 7 squared, it has an even index value, but 3 to the power 1 does not have an even index value. No, not an even index value. So we'll move on. Okay, these are questions that are sometimes asked then. Using the same skill or testing the same skill, what do we need to multiply these non-square numbers by? So they're telling you they're non-square numbers in order to turn them into squared numbers. So I'm looking at this and I'm happy 3 squared, that is an even power. But when I look at this, 2 to the power 3, what would I multiply 2 to the power 3 by to give you 2 to the power 4? And it is 2 to the power 1 or 2. So just write one of those down as your answer. So if I multiply it by 2 or 2 to the power 1, I've now turned it into a square number. Okay, the next question. You would put a 1 there. And when I look at this, that's cubed. To turn it into 2 to the power 4, I just multiply it by 2. And to turn 11 to the 1 into 11 squared, I multiply it by 11. So that is the answer, and some people would rather write it as 22. Okay, and the next one, I'm happy with the 11. Happy with 11 to the power 6, but I'm not happy with 2 to the power 3. What would I multiply that by to give you 2 to the power 4? And I would multiply it simply by 2 for the reason I've shown up there. Okay, and they're 1 mark questions on their own. So I'll put a few of these ready for you to try. So if you need to pause the screen, do so. There's 4 questions there for you to try. I'll come back to you in a moment. Okay, so I'll give you the solutions here. This is the section that I need to turn into 2 to the power 8, and I do that by multiplying by 2 or 2 to the power 1. I'm happy with the 3 squared. The next one, I need to change that to 2 to the power 4, so I do that by multiplying by 2. I need to change that to become 11 to the power 10, and I get that by multiplying by 11. So that is our answer, and some people would rather say times 22. I'm happy with 11 to the power 6 because that power 6 is an even index value, but I need to multiply 2 to the 5 by 2 to give me 2 to the power 6. I'm happy with the next question with the 7 squared part, but what do I multiply 3 cubed by to give me 3 to the power 4? And it's just simply 3. Okay, so that's those questions. And a very, very similar skill, but the only difference here is what would I divide, not multiply, what would I divide these non-square numbers by to turn them into square numbers? Okay, so once again, 3 squared I'm very happy with, but how do I turn 2 cubed into 2 squared? I'm using your skill with indices. 2 cubed divided by something turns it into 2 squared. Now, the division law of indices is telling me that this should be 2 to the power 1, because what you end up doing is you say 3, take away 1 gives you 2. So what's missing? You don't put times, you say you divide by 2 to the 1, or you can just write 2. You don't even have to say divide. Okay. The second one, I'm not happy with that. I need to turn it into 2 squared. How would I turn it into 2 squared? I divide by 2, or 2 to the 1. That 11 is actually meaning 11 to the power 1. So how do I turn that into 11 to the power 0? 11 to the power 1 divided by something is 11 to the power 0. I actually need to put in 11 to the 1 there. Okay, so my answer to the whole thing, so that's none happy with that. The answer to the whole thing is divided by 2 and 11, or some people would rather say divide by 22. And the last question, I'm happy with 11 to the 6 because it's got an even power, but this is something I need to change into 11 squared, so I just divide it by 2, or 2 to the 1. Don't write both answers down, either write 2 to the 1 or 2. Okay, the next one. Well, you try those questions and pause the screen when you're ready. So the answers to these, I'm happy with that. You multiply by 2. You divide by 2 because you want to turn that into 2 squared. I'm unhappy with that, so I would need to divide by 2 to turn it into 2 squared. I divide by 11 to turn that into 11 to the 6. Some people will say divide by 22. Okay, that is 2 to the power 1 if it isn't given to you. So you need to divide it by 2, or 2 to the power 1. I'm happy with 11 to the 6, so that is the answer, 2 to the 1 or 2. That is the one I need to divide by 3 to bring me down to, or 3 to the 1 or 3 to bring it down to 3 to the 6. I'm happy with the 7 squared. Okay, so that brings an end to that section. We're going to look at these now, highest common factor, lowest common multiple. So I'll just remind you very quickly what you would have done with easier numbers. The highest common factor of 10 and 12, I write the factors down. The factors of 10 are 1, 2, 5 and 10. The factors of 12 are 1, 2, 3, 4, 6 and 12. I would underline the factors, the common factors, should I say, and then the highest common factor is 2. Similar sort of skill you would use with multiples. You write your multiples of 10, 10, 20. Okay, those are the multiples of 10. The multiples of 12 are, and there it is. There's a common multiple, and it happens to be the lowest common multiple. The next common multiple is 120, but the lowest common multiple is 60. Now you'll have done that with easier numbers further down the school. So the next section, I'm going to show you an alternative method, which might not be the best method for those 2 easy numbers, but it allows you to work with large numbers. Okay, so watch this. If you put 10 as a product of prime numbers, it becomes 2 times 5. 12 is 2 times 2 times 3. Now I haven't put them in index form, they're just a product of prime numbers. So that's doing the work we did above. So what we do is we highlight or underline the common factors, and then we draw 2 interconnecting circles, like Venn diagrams. We draw 2 interconnecting circles. Okay, and what I do is I place the number 2, right? I place the number 2 in the center because it's common to both. And I place what's left is a 5 on the left hand side, and on the right I've got a 2 and a 3. So what I've gone and done is I draw 2 interconnecting circles. The number 2 is common to both, so I put it in the center. and the number 5 is on the left, and the number 2 and 3 are on the right. Okay, so the highest common factor is what was in the center. I'm just going to duplicate that here. We got a 2 and a 5. Let's just look up again. We got a 2 and a 3 left over. So the highest common factor is what was in the center, and I've highlighted that there, the intersection. And the lowest common multiple is multiplication sum with all the numbers in order. So it's 5 times 2. So multiply that by 2 times 3. Okay, so then I've got to multiply them out, which is the hardest part of it. 5 2s are 10. 10 2s are 20. And 20 times 3 is 60. So they give you the same answers as I had above with the easier method, except the only difference is we can now use this method with harder numbers. Okay, so I'll show you another example and then you can try some. Okay, sometimes you're given this, 28 is 2 times 2 times 7. Sometimes you'll have to work them out like we did above. So first of all, I'm going to highlight the common numbers, the common factors. They are 2 and they are 7. Okay, so we draw 2 interconnecting circles and we put the 2 and the 7 in the center. And we're left with a 2 on the left-hand side. That was with the number 28. And on the right-hand side, we're left with a 3. So as I said above, the intersection, the bit in the center, the intersection, I'll write these out here. You've got a 2, 2 and a 7 and a 3. The intersection, that's there is 2 times 7. So the intersection, the highest common factor is 2 times 7, which is 14. And the lowest common multiple is everything else multiplied together. It's 2 times 2 times 7 times 3. Now, 2 2s are 4. 4 7s are 28. 28 times 3, we may need to do that. 3 8s are 24. 3 2s are 6, and this 2 is 8. So it's 84 is the lowest common multiple. Okay. So there's a few questions underneath for you to attempt. You may need to pause the screen and press play when you're ready. Okay, so I'm going to highlight the numbers that exist on both. So there's a 2, and another 2. So I'm putting these in the center. On the left-hand side, I'm left with a 2 and a 2. On the right-hand side, I'm left with a 5. So the highest common factor is what's in the center, 2 times 2 times 2, which is 8. The lowest common multiple is everything there multiplied together. So it's quite a large calculation. 2 times 2 times 2 times 2 times 2 times 5. Okay. And after a period of time, you'll come to an answer of 160. Okay, so you might take a bit longer to do that. Question 2. Okay, you're given those bits of information, or you may need to calculate them. I'll highlight that these 2's are common, and these 2's are common, and that is it. So I'm putting the 2 values of 2 in the center, the intersection bit. I'm left with a 7 on the left-hand side. On the right-hand side, I'm left with a 2, a 3, and a 3. So once again, the highest common factor is what's in the center there. The highest common factor is 2 times 2, which is 4. the lowest common multiple is writing everything out. Don't forget, or should I say, don't miss anything out. 7 times 2 times 2 times the last 2 times 3 times 3. Let me check those. 7, 2, 2, 2, 3, 3. Yeah. Now that's obviously a difficult calculation, so I'm going to break it down into a 7. Now I know 2 times 2 times 2 is 8. And I know 3 times 3 is 9. So maybe you need to say 7 eighths. 7 times 8 is 56. And then 56 times 9 is 504. Okay. There's your lowest common factor and highest common multiple. Sorry, your highest common factor and your lowest common multiple there. And the last one is this. So the 3 is common there and the 5. Okay, so I'm putting 3 and 5 in the center. I'm left with a 7 on the left. I'm left with a 2 and a 3 on the right. Okay, so the highest common factor is what's in the center, which is 3 times 5, which is 15. And the lowest common multiple is writing them all out. So this calculation, I say, can be quite difficult. 7 times 3 times 5 times 2 times 3. Personally, I would have broken that down to 7 times 15, which is 105. And then 2 times 3 is 6. So it's 105 times 6, giving me 630. I'll just give you the answers to the next one. The common ones are here, the 3 and the 5. Okay, so 3 and 5 go in the center. I'm left with a 7. I'm left with a 2 and a 2 on the right. So the highest common factor, once again, is 15. And the lowest common multiple is everything else put together. 7 times 3 times 5 times 2 times 2. Okay, so personally, I would do 7 times 15, because that section is 15, times 4. All right, and eventually you get 420. Okay, I'm just going to summarize some of that for you now. Yeah, here we are. So when you express a value as a product of prime numbers in index form, you keep dividing. You keep dividing by the lowest possible prime. Stop when you get to a 1 at the bottom. Write them out as a product, that's a multiplication sum, and then you put them in index form, like 2 cubed, 3 squared, and so on. All squared numbers have even index values, such as 5 squared. I know that's a squared number because that's even. You could have that there, so that very large number I know is an even index value. Sorry, that large number is a squared number because they got 2 even index values. When we look at the highest common factor and lowest common multiple, the highest, so we list when you've got product of both values, you highlight what's common on both. You put the common values in the section, the intersection here, and you'd multiply the values that are in there to get the highest common factor. And the lowest common multiple is everything you see in the both or the 3 sections. Okay. I hope that was useful. I would take your time and play it again as a form of revision. Thank you very much. Next week, it's my intention to go through, let me just check. Venn diagrams. Okay, so next week I'm going to do Venn diagrams. Thank you very much for myself and Miss Jones.